Today we are following spies around. We are summing the sequences of consecutive numbers in an array. We are playing the deaf rats with the Pied Piper. We are determining the length of the longest palindrome in a string. And then we are building an assembler interpreter. Hello world, and this is Versus Codewars. And I hope everyone is having a wonderful and safe day today. We begin our warm-up segment today with the quintessential programming interview question, the Fizz Buzz problem. The goal of this kata is to return an array containing the numbers from 1 to n, where n is the value passed into our kata solution here. Replace certain values, however, if any of the following conditions are met. A. If the value is a multiple of 3, use the string fizz instead. B. If the value is a multiple of 5, use the string buzz instead. Or C, if the value is a multiple of both 3 and 5, we use the string fizz buzz instead. Alright, let's go ahead and get started with this one. We'll do const fizz buzz. We'll have our n here as the lone parameter here. Since we are returning an array, we are going to go ahead and do const result. We're going to set that into an empty array at first, and we are going to go ahead and return that. And we're going to do a little for loop right here for let I equals 1, I is less than or equal to n plus plus I. Now, in order to determine if a number is a multiple of another number, we are going to do a modulo operation here, in which we take the first number, we divide it by the second number, and then we get the remainder of that division here. And if that remainder is 0, then the first number is in fact a multiple of the second number. So, with that in mind, let's do this. If I modulo 3 is equal to 0 and I modulo 5 is equal to 0. That way we know I is a multiple of both 3 and 5. And we'll do this. Result.push. We'll push in the string fizz buzz right here. Alright. If our number is a multiple of just 3, we will push in the string fizz. If our number is a multiple of 5, and not 3, we'll push in the string buzz. Otherwise, if our number is not a multiple of either 3 or 5, we'll just go ahead and push in our number right here. Alright, let's go ahead and punch this into Codewars to see what this looks like here. I'm going to run these tests here. And we are good on that. For our next warm-up kata, we are playing around with the ArrayObjects filter method. JavaScript arrays support the filter method since JavaScript 1.6. Using the filter method, the goal of this kata is to take an array of numbers and remove any odd numbers from that array. Let's go ahead and get started with this one here. I'm going to add a little bit of a catch here. We're going to do a little prototyping here and implement our own version of the filter method here. So what we're going to go ahead and do, first we're going to go ahead and create the function signature here, get even numbers, and we'll have our array of numbers right here. However, above that, we are going to do our own filter method here. So array.prototype.filter. And since we're using a prototype, we got to use the ES5 syntax here. And we're going to have our predicate function right here. Now, what we're going to go ahead and do, we're going to go ahead and do a result array right here, and that is going to be what's returned right here. Now, we're going to go ahead and iterate through the elements of our array here. So for let I equals 0, I is less than this dot length plus plus I. And what we're going to go ahead and do is if we call our predicate function passing in the element of the array at this index, the index itself, and the array, and if this predicate function returns true, we will go ahead and push this element into our result array right here. And this will be our implementation of the ArrayObjects filter method. Alright, with that being said, let's get to our Kata solution right here. What we'll go ahead and do, we are going to take this numbers array and we are going to run that through our custom implementation of the filter method here. Numbers.filter. And we'll have our predicate function right here, passing in our number. And we are going to return true if the remainder of number divided by 2 is 0, indicating that the number is even. Alright, let's go ahead and actually test this out here. We're going to do a console.log get even numbers. We're passing 2, 4, 5, and 6 here. Let's feed this into Node to see what this looks like here. Node warmup array filter. And we get undefined here. Why are we getting undefined here? Alright, let's go ahead and console.log our result array here. It seems our function isn't even running here. Alright, let's go ahead and rename that my filter here. So I'll make that in no uncertain terms. Let's try that again here. Undefined. Why are we getting undefined here? Are we even calling that? Alright, I'm gonna go ahead and do return. We're gonna do a console.log up here. That's strange, the console.log isn't even running here. Oh, right. Or I'm an idiot. Apparently what happened here was I put the parentheses in the wrong order here. So this should be correct now. Let's try that again here. And we do get... yeah, let's go ahead and correct that here. And we do get our filtered array right here. Sorry about that. Alright, let's go ahead and punch this into Codewars to see what this looks like here. I'm going to run the tests. And we are good on that. That's why we call it the warm-up segment here. Anyway, for our next warm-up kata, we are given a number, and we have to compute the series of numbers starting from 0 and ending until the given number. And we actually have to return the string form of our equation here. So, I'll call your attention to the examples in the kata solution here. Given the number 6, we have to add the numbers starting from 0 and going to 6. Not only that, we actually have to print out this addition sequence right here in addition to our sum here. And here are our edge cases here. We have minus 15, which is less than 0, so we return this. And we have 0 itself, so we end up returning this right here. Alright, let's go ahead and give this one a try here. Const sequence. Ooh, yeah, looks like we have an immediately invoked function expression here. This looks like a very interesting little sequence here. Alright, I'm gonna go ahead and copy this over to our local solution here. Obviously replace this with const. Alright, what we need to do... First of all, if our count is less than 0, then we'll just go ahead and return a template string that says count is less than 0. And else if our count is equal to 0, then we'll return 0 equals 0 here. Alright, with those edge cases out of the way here, what we need to do now, we'll go ahead and keep track of a result string here. And a result value here. I think we'll go ahead and put 0 here. And what we'll go ahead and do, for let I equal 1, I is less than or equal to count plus I. And what we'll go ahead and do, the result value plus equals I, and then result string plus equals, in a template string here, plus I right here. And then what we should be able to do at the end here, what I think we should be able to do is return in a template string our result string equals result value right here. And now, this is certainly a strange looking signature here. Let me have a look at the tests here and see what they look like. Yeah, okay. Alright, let's go ahead and test this out here then. Console.log sequence sum dot show sequence. And we're going to go ahead and pass in the number 6 here. Let's punch this into node to see what this looks like here. Warm up sum to n. And we get the signature 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 equals 21. Which is what we want to see up here. Alright, let's go ahead and test out our edge cases here. Minus 15. And we get the string minus 15 is less than 0. And let's try 0 here. We get 0 equals 0 here. Alright, I think we're ready to punch this into Codewars to see what this looks like here. Let's run this test here. And let's hit attempt. And what is going on here? Negative and 0 test. Oh, okay. Just need to go ahead and get rid of the spaces here and the 0 equals 0. Let's go ahead and punch this one in here. And what's going on now? Likewise for our negatives here. Could have been a little more clear about that in the Kata instructions. But okay, let's go ahead and punch that in. And we are good on that. For our next warm-up kata, we have to complete the function power of 2, which determines if a non-negative integer is a power of 2. Alright, let's go ahead. A power of 2 is a number of the form 2 to the power of n, where n is an integer. The result of exponentation with the number 2 as the base and integer n as the exponent. Alright, for the sake of this kata, our inputs will always be valid. Alright, let's go ahead and get started with this one here. So we gotta check to see if the number given is a power of 2. So const is power of 2. We'll have our number right here. And what we'll go ahead and do with that number is, I think we'll start with our index right here. Or rather, yeah, let index equals 0. And then while index, or rather 2 to the power of index is less than n here. Or rather, let's do a while true here. And then if index, or let power equals index to the 2 to the power of index. Then if power is equal to n, we return true. Else if power is greater than n, we return false. And then we'll go ahead and increment our index here and continue with that right here. Alright, let's go ahead and test this out here. Console.log is power of 2. Let's pass in 1024 here. Alright, node warmup power of 2. Okay, I'm pretty sure that is supposed to log something here. Let's make sure I call that right here. We'll do console.log here, power. And we'll pass in n here as well. That's strange. Yeah, okay. It's returning true here. Alright, let's go ahead and try another number here. 4096. Also true. Let's pass in 333 here. I expect this to return false. Let's try a rather large number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5. A very large number here. And it does return false here. Okay, let's go ahead and punch this into Codewars to see what this looks like here. Alright, let's hit test. And let's hit attempt. And we are good on that. And finally, we are rotating for a max. I'll call your attention to the Kata instructions here. Let us begin with an example. Consider the number 56,789. Rotate the digits of this number one place to the left, wrapping around the first digit to the last, and you get the number 67,895. Next, we keep the first digit in place and rotate the remaining digits one place to the left, in which case the second digit becomes the last digit. And we get the number 68,957. Next, we keep the first two digits in place and rotate the remaining digits one place to the left, in which case 68,957 becomes 68,579. And then finally, we keep the first three digits in place and rotate the remaining two digits one place to the left. And then as a result, we get the number 68,597. Now the rotating is over, since keeping the first four digits results in only one digit, which would be rotated in and of itself. And that gives us the sequence of numbers right here, as you see here. And the goal of this kata is to return the greatest number of that sequence, which should always be the last number of that sequence. The goal of this kata is to write the function which, given a positive integer, returns the maximum number that you get doing the rotations, similar to the example given right here, up here. Alright, let's go ahead and give this a try here. I'm going to hit train. This would actually be called warm-up rotate 4 max. So, anyway, const max rot, and we have our number right here. And what we need to do, first we need to go ahead and take the digits of our number, get the digits of our number here into an array. So, we'll do const digits equals, we're going to go ahead and spread the number to a string here. And then map those characters out into integers themselves. Alright, what we will do now is, I think we'll use a temporary swapping function here. We'll use a helper function here. Swap equals first and I don't know if that's gonna work here. Anyway, what we are going to go ahead and do, we'll do for let I equals 0 for the we start the first digit here. And then I is less than or equal to digits dot length minus 2, I think, plus I right here. I'm gonna go ahead and console.log that here, digits at I. I'm gonna go ahead and do a console.log down here, max rot. I'm going to pass in that 5, 6, 7, 8, 9 here. And we're going to go ahead and punch this in a node to see what that looks like here. Warm up, rotate to max. And we get 5, 6, 7, and 8. And we are doing 4 rotations here, so I think that is what we want to see here. Alright. Let's go ahead and we're going to go ahead and do a temporary variable here. Temp equals digits at I. Or digits at I. We'll set that equal to digits at digits dot length minus 1. And then digits at digits dot length minus 1 will be set equal to temp right here. A little swapping here going on here. Alright, let's go ahead and console.log our array each time here. Console.log digits right here. And let's go ahead and oh, wait a minute. Yeah, we're approaching that entirely wrong here. Oh, right. Okay. What we actually need to do is we're going to do digits. Actually, okay, I have another idea. Const keep. Set that into an array here. What we'll go ahead and do here. No. Okay, we got it. First, we go ahead and take this first digit and move it to the end here. Okay, I think I have an idea as to where this is going here. Const mod equal modify equals digits.slice from I, and then const keep equals digits.slice from 0 to I here. And then what I think we'll go ahead and do at the end here, digits equals, we'll spread out to the keep first, and then the modify. And then what we'll go ahead and do with the modify array here, we'll go ahead and modify dot push to the end the return of modify dot shift. And then we'll go ahead and console.log our digits down here. Let's see what that looks like. Assignment to constant variable. This needs to be let up here. This needs to be I instead of 1. Then we get 67895, 68957, 68579, and 68597. And that is what we want to see here. Alright, what we'll go ahead and do, we'll go ahead and return parse int digits.join with a blank string separator down here. Running that, we get 68,597, which is what we want to see according to this Kata example right here. Alright, let's go ahead and try another number here. Let's have a look at the tests here. How about this large looking number right here? 9621. Oh. Okay, oh, it looks like we've actually got to return the greatest numbers of this sequence here. Okay, what we'll go ahead and do, const sequence, we'll set this to an empty array here. And what we will go ahead and do is sequence.push digits.join with a blank string separator here. And we'll go ahead and wrap that in parse int. And then we are going to go ahead and console.log our sequence down here. And 9621. And then we can go ahead and return the maximum value of the numbers in that sequence. Alright, let's go ahead and run that through Node and see what that looks like. And it looks like we do receive the correct number now. Let's have a look at another number here. Test this out. I believe that is 195,881,031, and we get the number 988,103,115, which matches up with this test right here. I think we're ready to punch this into Codewars to see what this looks like here. I'm going to hit test, and we are going to hit attempt, and we have a problem. What is going on here? Oh, that's a 9-digit number here. 507,992,495. Alright, let's go ahead and console.log that sequence again. Oh. Oh, that would be why. You have this 0 here. Oh, great. We gotta account for that. Oh, wait a minute. Oh, duh. You know what? I was actually forgetting to account for the initial number that we passed in. What we have to do is to initially populate this array here with the number that we pass in here. That's got to be the first number of our sequence. Let's try that again here. Alright, let's go ahead and get rid of this console.log. I think I've got it here. Let's go ahead and punch this into Codewars to see what this looks like here. We are going to go ahead and hit test, and we are going to go ahead and hit attempt, and we are finally good. Boy, that was a doozy. Glad I figured that one out, though. That concludes today's warm-up segment. I will see you in the next kata. We are following a spy. We are tracking down our rogue agent, Matthew Knight, also known as Roy Miller. He travels from places to avoid being tracked. Each of his travels are based on a list of itineraries in an unusual or incorrect order. The goal of this kata is to determine the routes he will take in his every journey. We are given an array of pairs representing his routes in his itineraries. The goal is to list down the only places where he will go in the correct order based on those itineraries. I'll call your attention to this example in the kata instructions here. Here we have an array of pairs of country codes representing his routes here, and the resulting string representing the route he will travel will be right here. Note we have our first two countries right here in this first pair right here. The next country he will visit will be the pair in which the first element is the same as the second element in the previous pair, and so on and so forth. It is safe to assume that there will be no repeating place with a different route. There are no empty routes, and there will be at least one route from one waypoint to another. Let's go ahead and get started with this one here. Const find routes. And we'll have our routes right here. Now, what we'll go ahead and do, we are going to go ahead and keep track of a result string right here. And it's going to start with the first two countries of our pair right here. And we're going to do routes at index0.join with a comma and a space, I think. Yep. Alright, we are going to go ahead and take one of our tests down here. I'm going to take this call to find routes right here. And we're going to do console.log down here. Alright, let's go ahead and run this thing node. Punch this into node to see what this looks like here. And we do need to return that result right here. And we do have the first two countries of our spies route right here. The goal is to find the rest of them. And what I think we will go ahead and do, we're going to do a index right here. And inside that index, we are going to... actually, we're going to do a while loop here. While true, we are going to let index equal next index equal routes.find index. And in that predicate function, we're going to have our pair right here. And we are going to return okay. Let last index equals 0. We are going to return true if the pair at index 0 is equal to the pair in our routes array at index last index. And then if that index is equal to -1, we will break out of this loop. Otherwise, what we need to go ahead and do I think instead of an array here, a string here, we should do an array. Routes at 0 at 0, and then routes at 0 at 1. Or rather, we'll do a spread up here. Routes at 0 up here. And then what we'll go ahead and do, we'll do result.push routes at index 1 right here. And then we need to go ahead and set our last index to the index here. Alright, let's run this through Node to see what this looks like here. And I do not believe that was what I was expecting to see here. Routes at last index at index 1. Let's try that again here. Alright, we do have that array right here. And that does match up with what we were seeing in that test here. Finally, what we need to do, we need to join all that together with a comma and space here. Alright, I think we're ready to punch this into Codewars to see what this looks like here. Copy and paste. Run the tests, and what is going on here? Alright, let's go ahead and console.log our pairs of routes here.
Chicago, Winnipeg, Seattle. Now, wait a minute. Oh, wait a minute, okay.
Ah, yes. Okay, let's go ahead and... Alright, what we actually need to go ahead and do is... Okay, I have a new idea here. I think we need to branch out to the left and to the right here. So, what I think we'll go ahead and do, I'm going to go ahead and get rid of this up here. And what we are going to go ahead and do, let's start branching out to the left here first. So, while true, let index equals routes.find index, or rather, yeah, routes.find index. We'll have a route here. And then what we'll go ahead and do, now the place our spy will be before this place ought to be okay, let's go ahead and console.log our routes just to keep a reference to that. And what we're going to go ahead and do, we're going to go ahead and take this array here in one of our failed tests here. We're going to paste that in here. And we're going to run that through Node to see what that looks like. Alright, I have an idea. What we'll do, alright, we have our first routes right here. Result, how about result at index 0? Is equal to our route about our route at index 0. And then if index is equal to -1, then we break. Otherwise, we do result.unshift. And then we unshift that route at index 0 here. Routes at index at 0. Alright, let's go ahead and actually return that result array here. No, that's supposed to be a start point here. Okay. Oh, wait a minute. Let's try that again. Yeah, we have our Chicago and Winnipeg here. And then Winnipeg to Seattle. Okay. Alright, I think I'm on to some here. Alright, let's go ahead and repeat that with... Alright, we'll go ahead and reset our last index here. And we'll do while true again down here. And we're going to do the same thing we did up here. Let index equals routes.find index. We'll have our route right here. And then this time, what we'll go ahead and do, we'll return true if the result at the end of our array is equal to our route pair at index is 0. And then if index is equal to -1, we will go ahead and break out of that here. Otherwise, we'll do result.push routes at index. I think it is going to be index 1 of that pair. Alright, let's go ahead and run that through Node to see what that looks like here. And we have Halifax, Montreal, Toronto, Chicago, Winnipeg, Seattle. Alright, I think that is good to go. Let's go ahead and get rid of these console.logs up here. And let's look at another one of our failed tests here. I'm going to copy this array here. And I'm going to go ahead and paste that array right here. Alright, let's run that through Node to see what that looks like. Alright, this test expects Seoul, Ljubljana, Wrocław, Nashville, Amsterdam, Hull, Vancouver, Agra, Tokyo, and Manila. I think this is good. Let's go ahead and punch this into Codewars to see what this looks like. Alright, let's hit test. I've got it. Uh-oh. Yeah, that would be because we need to join our results together here. Join with a comma and a space. Alright, let's try that again here. Let's go ahead and reflect that in the Kata solution here. Alright, all those tests have passed. Let's go ahead and hit attempt. And we are good. Boy, was that ever a heavier lift than it needed to be. I was under the assumption that the first 2 countries our spy would be visiting on his route would always be the first pair of countries in the given array. As it turns out, that was not the case, as the starting point is actually the pair of countries in that array, in which the first country given is not the second country in another pair in that array. So, what I had to do was 2 while loops instead of 1. The first one would travel back in that route, looking for a pair in that pair of arrays in which the second country in that pair was the first country in this current pair here. And that's how I would traverse back in that route. And then I would use a second while loop, doing something similar, only traversing forward in that route, looking for a pair of countries in that array, in which the first country of that pair would be the second country of the current pair, continuing until we reach the end of our spy's journey here. And as it turns out, I would not have needed that last index variable either. For this kata, we are given an array which contains only positive and negative integers. The goal of this kata is to sum only the numbers that are the same and consecutive. The result should be one array. Let's go ahead and give this one a try here. Alright, const sum consecutives And we'll have our array of numbers here. Alright, we'll go ahead and have a result here. And we are going to return that right here. I think we'll go ahead and keep track of a current here. Alright, what we're going to go ahead and do. We are going to go ahead and I think we'll go ahead and iterate over our numbers here for let I equals 0, I is less than numbers.length minus 1 plus I, because we are going to be looking up the next number in that sequence here. Alright, I think what we'll go ahead and do. We'll go ahead and set our current numbers at index 0 here. Or rather, yeah, 1. And if numbers at I is exactly equal to numbers at I minus 1, then what we'll go ahead and do, we are going to go ahead and add to our current here. Otherwise, what we'll go ahead and do is we are going to push our current into our result array, and then we'll do current equals numbers at index I. That should be enough here. Let's go ahead and grab this array here. We're going to do console.log sum consecutives, and we're going to pass that in right here. Right, let's go ahead and test this out here. Node sum consecutives. And we get the array 1, 12, 0, 4, and 6. And that actually is not what we want to see here. 4, 4, 4, 12, 0, 4, 3, 6. And then 1. Alright, what we'll go ahead and do then, at the end here, we'll do I think. And then if I plus 1 is equal to numbers.length, meaning we're at the end of the array here, we'll also push that there too. Alright, let's try that. And we get that 1 at the end too. Alright, how about, let's try a couple other arrays here. How about this one? 1, 1, 7, 7, 3. We should get 2, 14, and 3, and we do. How about this array right here? This array is minus 5, minus 5, 7, 7, 12, and 0. And that should give us 10, 14, 12, and 0. Whoops. Yeah, get out of here. All right. Let's go ahead and punch that in the node to see what that looks like. And we do get minus 10, 14, 12, and 0. Alright, I think we are good to punch this into Codewars to see what this looks like here. Alright, let's go ahead and hit test. And we are good. Here is the better code solution of the day. Pay mind to the code snippet you see to my left here. First, we take our array and run it through the reduce method. In this particular case, the predicate function will make use of all 4 parameters. First is the accumulator, which will be set to an empty array. Next is the current element of the array. Next is the index of that element. And then, finally, we have the array itself. First, we check to see if the current element is equal to the element of our array at the index before it. If it is not, we go ahead and push that current element onto our accumulator array. Otherwise, we will take the element of the accumulator array at the very last index and add to that element the number at that current element. And then we will go ahead and return that accumulator array for the next iteration of the reduce method. The Pied Piper has been enlisted to play his magical tune to coax all of the rats out of town, but some of the rats are deaf and are going the wrong way. The goal of this kata is to find out how many dead rats there are. Alright, we are going to be given a string as the lone parameter in this kata solution. This string represents a map of the town, a one-dimensional map of the town. And the legend is as follows. The Pied Piper is represented by the capital P. The rat going left is denoted by the capital O and then a tilde. And then the rat going right is represented by the tilde followed by the capital O. The goal of this kata is to find out how many rats are traveling towards the Pied Piper. Right, let's go ahead and get started with this one here. Alright, I'm going to go ahead and we're going to go const count def rats. And we are going to have our town here, the string representing our town here. And what we are going to do, alright, I think what I'm going to go ahead and try doing, we're going to go ahead and split this town string into substrings. And these two substrings will represent either side of the Pied Piper. I'm going to go ahead and set up some constants here. Const Pied Piper. Going to be represented by the capital P. Const left rat represented by, or rather left rat regex here. Give me one moment here. Const left rat regex equals, I think I'm going to do, this is going to be the O followed by the tilde here. And then the right rat regex here. Just like that. Alright, what we're going to go ahead and do, we're going to do a const left side and then right side. We're going to do a destructuring assignment here, and we're going to set that to town, split. And the character we are going to split with is our Pied Piper character, the capital P. Alright, I'm going to go ahead and console.log the left side and the right side, just to show you what this looks like here. I'm going to grab this string from the kata instructions here. I'm going to go ahead and do console.log count dead, or def, excuse me, rats. I'm going to paste the string right here. I'm going to feed this into Node to show you what this looks like here. What the left side and right side of town looks like. Node def rats. Oh, that's interesting. Oh, yeah. Here we have the left side of town and then the right side of town right here. Now, what we're going to go ahead and do, we're going to use our regular expressions to find out which of our rats are heading towards the Pied Piper and not away from town. That's going to indicate how many dead, or rather deaf rats that we have. Alright, first we'll go ahead and check out the left side here. Rat going right, rat going left. Okay, I'm going to go ahead and grab a different string here. Maybe try to make this a little easier on myself here. And we're going to go ahead and, first we're going to go ahead and check out the left side here. what I think we'll go ahead and try doing here, left side dot, we're going to go ahead and do a little console.log here. Left side dot match. We're going to pass in, I think we are going to pass in, or rather, I'm going to do the right side here in the case of this particular string. We're going to pass in the regular expression for our rat traveling right. Right rat regex. And we're just going to go ahead and see what that looks like here. Right string, right side. And we have this one rat going the wrong way here. And likewise, what we're going to also go ahead and do is console.log left side dot match, and we're going to pass in our left rat regex right here. All right, I'm going to go ahead and bring this string back into the fold here. I'm going to paste this in here. Now, wait a minute. Okay, I don't think regular expressions are going to be the way to go here. Yeah, okay, I don't think regular expressions are going to be the way to go here. Alright, I'm going to go ahead and do something else here. Alright, what we're going to go ahead and do, we're still going to go ahead and split our string with our Pied Piper character here. So const left side, right side equals town.split. We'll pass in our capital P right here to represent the Pied Piper. And then we got our rats heading towards the Piper here, represented by the tilde capital O here on the left side, and the capital O tilde on the right side here. All right. Now I know we probably got to use some kind of regular expression to pick these up here. Now, I think I have an idea here. I think we'll go ahead and we'll need to make this a let here, and I think we'll go ahead and keep track of a count here. Let def count, set that equal to 0, while left side dot length is greater than 0. And then what we'll go ahead and do is if left side dot slice, and we'll go ahead and slice from 0 to 2 is equal to a rat traveling right here. And we'll have an else case, right? Yeah. Or rather, the rat traveling left. And then we'll go ahead and increment our def count here. And then we'll go ahead and pop those two characters off of the string. Does the string method have a splice method? Does a string object have a splice method? Left side dot splice? No. Okay, yeah, okay, I have an idea. Left side equals left side dot slice 2 then. Alright, let's go ahead and console.log our left side here. Run that through node, and I think that is working here. Alright, let's go ahead and repeat this for our right side here. I think we can accomplish this in the same while loop here. While left side dot length is greater than 0 and right side dot length is greater than 0. So what we'll go ahead and do, if right side dot slice, and in the case of the actually, we can go ahead and do the same thing here too. If the first two characters of the right side string is equal to the rat going left here, or rather the rat going right, then we'll increment our def count again here, and then we'll repeat this with the right side string here. Alright, running this through node, we actually need to return our def count here. And we do get 2 def rats here. Now, let's go ahead and pass in our other string here. One def rat. Okay, we come to maybe an invalid character here. Alright, what we'll go ahead and do, if left side at position 0 is a space, then we'll go ahead and do left side equals left side dot slice. We'll slice 1 from that. Okay, what we'll do here, right side 0 is equal to a blank space. And then we'll go ahead and do the checks individually in here. And then we'll continue. Let's see how that works. And we have that one def rat here. Okay, let's have a look at some of the tests here. And that is all of the tests in there. Let's go ahead and punch this into Codewars to see what this looks like here. I'll go ahead and hit test. We're going to go ahead and hit attempt, and we are good. What I was initially going to go for with this Kata solution was to use regular expressions on the left side and the right side of the piper in order to pick up which rats were heading in the wrong direction. What I was failing to account for is that those regular expressions would actually pick up the head part of one rat and the tail part of another rat, thereby giving me incorrect results here. What I ultimately went ahead and did was use the slicing method here do a while loop that continued while the length of at least one of the two strings was greater than 0. I would go ahead and check to see if the first two characters was a rat going in the wrong direction, and if it was, I would increment the def count, the number of def rats that would be in this particular town string here, and then slicing those first two characters off of the string. What I was failing to account for at that point was the possibility of invalid characters like spaces here. So I would have to go ahead and check to see if the first character in the current modification of our town strings was a space. And if it was, I would slice those off and continue with the while loop. Therefore, I would go ahead and be able to get the correct number of def rats. For this kata, we are given a string, and the goal is to find the length of the longest substring in that string that is the same in reverse. In other words, we are looking for the longest palindrome in the string. Let's go ahead and give this one a try here. Const longest palindrome. We're going to have our string right here. Alright. First, we need to go ahead and check to see if we have a blank string here. If string is equal to, if the string is an empty string, we'll go ahead and return 0. Now we're going to go ahead and do let's palindrome length. We're going to set that equal to 1 here. And what we're going to go ahead and do, we're going to go ahead and do let substring length equal 2. We'll do another edge case right here. Else if string.length is equal to 1, we'll just go ahead and return 1 here. Alright, now let's go ahead and I think we'll go ahead and do a while loop here. While no. What we're going to go ahead and do for let I equals 0, I is less than what I think we'll do is string.length minus substring length minus 1 plus I here. And we'll go ahead and shrink this view here. What we're going to go ahead and do. Alright, we're going to go ahead and get a slice of this string here. I think we might want to go ahead and split that into its individual characters as well. No. Alright, we're going to go ahead and const sliced and reversed. And what we're going to go ahead and do, we're going to take the string here. We're going to slice it from the current index and going to I plus substring length. I think that's exclusive here. I'll go ahead and console.log that here. Sliced and reversed. Alright, I'm going to go ahead and grab this string right here. Do a console.log longest palindrome. We're going to pass this in right here. We're going to feed this a node to see what this looks like here. Node of longest palindrome. Seems to be substring length is not defined. Let's try that again here. ZZ, ZB, BA, AA, BC, D. Okay. Alright, what we're going to go ahead and do. Just going to go ahead and call this sliced here. And we'll do const reversed here. Sliced dot. We're going to take that, split it into its individual characters, reverse it, and then join it back together. And then if sliced is equal to reversed, we're going to go ahead and reset our I counter here. Set our palindrome length equal to our substring length. We're going to increase the length of our substring length here. And then we're going to reset our I counter here. Then we'll hit continue. And then if this string reaches, if we reach the end of this for loop here, then we know what the length of the longest palindrome substring in our string is. We'll go ahead and return palindrome length down here. All right, let's go ahead and run this here. And do not want to see that here. All right, let's go ahead and console.log our sliced string here. That's easy. That's interesting. All right, I'm gonna go ahead and console.log our I and our substring length up here. All right, we'll go ahead and get rid of our I step here. And we'll put that I step right here. All right, I'm gonna go ahead and do this down here. Sliced, reversed. ZZZZ. All right, what we'll go ahead and do. All right, I'm gonna go ahead and rethink this one here. Let's try this. While substring length is less than the length of our string. And then we'll go ahead and increment that down here. All right, let's see what we can do here. For let I equal 0, I is less than string.length minus substring length minus 1, then plus plus I down here. Then what we'll go ahead and do, we'll go ahead and slice our string here. String.slice and then I plus substring length. And then we'll do reversed. We'll set that equal to. All right, we'll split our slice string into its characters, reverse it, and then join it back together. And then if sliced is equal to reversed, we will go ahead and set our palindrome length equal to our substring length. And then I think we can go ahead and break out of the loop at this point here. All right, let's see how this works here. And we have our longest palindrome length here. I would imagine that there will be some very long strings here. That's... Uh-oh, that's not good. Alright, we're going to go ahead and do console.log sliced reversed here. And I'm going to clear the terminal. Maybe it's this for loop here. Nope, that ain't it either. Let's try -2 here. Nope. Alright, what's going on now? Maybe it's less than or equal to here. Yep. Alright, let's go ahead and bring back that other string here. ZZBAABCD. Just gotta make sure the entire string is being checked here. Let's have a look at some of these tests here. How about this long looking string here? Ooh, that did take a little bit to run here, but it does give us the right return value here. All right, let's go ahead and get rid of this console.log here and see how that impacts the performance. It did impact it quite a bit, and we still got that correct number here. All right, let's go ahead and punch this into Codewars to see what this looks like here. I hope we don't run into very long strings here, or else we're gonna have a problem. And as it turns out, we are going to have that problem. Let's go ahead. Oh, never mind. We are good. As you saw, I am really very lucky that the final tests of my Kata solution did not time out here. There was a lot of brute forcing here, and this solution was not very performant. Here, however, is a more performance solution and another better code solution of the day. Pay mind to the code snippet you see to my left here. Here we actually start iterating from the end of the string to the beginning. And inside that for loop, we have another for loop iterating from the start of the string towards the end. Now, inside the body of this double for loop, we get a substring from the index of the inner for loop all the way to the index of the outer for loop. We take that substring and we reverse it and join that back together, and then we compare the two strings. And if they are the same, then we know that's the longest palindrome. We are going to go ahead and return the current index of the outer for loop, because that is the length of the longest palindrome of our string. This is a lot more performant than my Kata solution here, and I really should have done better to account for the performance of my Kata solution. For this Kata, we are to create a simple interpreter of an assembler which will support the following instructions. MOV XY copies Y, either a constant value or the content of a register, into register X. IncX increments the content of register X by 1. DecX decrements the content of register X by 1. JNZXY jumps to an instruction Y steps away, positive meaning forward, negative meaning backward. Y can be a register or a constant, but only if X, a constant or a register, is not 0. Register names are alphabetical, letters only. Constants are always integers, positive or negative. Note the J and Z instruction moves relative to itself. For example, an offset of -1 will continue at the previous instruction, while an offset of 2 would skip over to the next instruction. This function will take an input list with the sequence of the program instructions and will execute them. The program ends when there are no more instructions to be executed, and then it returns an object with the contents of each of the registers. Also, every ink, deck, or J and Z on a register will always be preceded by an MOV on the register first. So we don't need to worry about uninitialized registers. Alright, let's go ahead and give this one a try here. Const simple assembler. We are going to have our instructions here, which is going to be an array. Alright, what we will need to do. I think we'll go ahead and keep track of an instruction pointer. Set that equal to 0. And what we'll go ahead and do, while instruction pointer is less than instructions .length. Alright, first we'll need to go ahead and interpret the current instruction here. What we'll do is const instruction equals instructions at instruction pointer. And then what we'll go ahead and do, it looks like each of these instructions will have no more than 3 parameters here. So const command, we'll do a destructuring operation here. Command first, second, and we'll set that equal to instruction, and we'll split that into its individual tokens with a space separator here. Alright, I'm gonna go ahead and cancel. We're gonna go ahead and increment our instruction pointer at the end here. And I'm just going to go ahead and console.log each of our instructions here. Command first and second. Alright, well, we're going to go ahead and grab this list of instructions here from the Kata instructions here. I'm going to do a console.log. We're going to go ahead and do simple assembler in an array. Put these in an array here. Alright, let's run this through Node to see what this looks like here. Node ASM. And as you can see, we have each of our instructions here. Don't worry about the undefineds that you see right here. These are the instructions that only have 1 parameter passed in. As you can see, we start with this MOV command, and we have our register A here, and we set and copy this register here to this value here, rather, 5, to our register here. So let's go ahead and implement that one first. If command is equal to MOV. Alright, we'll go ahead and check. First, we need to check to see if this second argument is a letter or a number. If it's a letter, then we know this is probably going to be another register. Speaking of, by the way, let's go ahead and create this object here, registers. We'll set that equal to an empty object for now. Alright. First, we'll go ahead and check to see if the first argument is numeric. And what we'll go ahead and do, I think it's isNumber. If number.isNumber is integer, we'll pass in our our second argument here. If that is true, then we will go ahead and we'll do our registers, and we'll take the register that we pass in as the first argument here, and we'll set that equal to second here. Now, if our second argument is not a number, then we know that this is going to be referring to a register that was already in place here. So, else, we are going to take our registers at the first parameter, and we'll set that equal to the value of the register in the reference in the second parameter right here. Alright, the next argument that we need to implement is the inc command, which increments the value of the given register. And so what we'll do is we'll do else if command is equal to inc. So we'll take our, well, first of all, if our register, if there is no register at that given, if there is no such thing as the given register here, I'll just say, yeah, if registers at first, we'll just go ahead and implement that right now. And then we'll go ahead and do registers first plus plus. Actually, we might actually not need to check that here, because keep in mind the Kata instructions here, every command on a register will always be preceded by a copy command on that register first, so we don't need to worry about uninitialized registers. But it's always a good idea to check to see if that register exists first. It's always a good idea to check for those kinds of bugs and avoid those vulnerabilities if possible. Alright, anyway, what we'll go ahead and do next, else if command is equal to DEC, we'll go ahead and decrement the value at that register. And finally, there is the JNZ command, which tells our interpreter to increment or decrement the instruction pointer by the given amount. So, only if x is not 0. So if instruction pointer minus first is less than or equal to less than 0, then we'll go ahead and set instruction pointer to 0. Otherwise, we'll do instruction pointer minus, or rather plus here, plus equals first here. And then once we reach the end of our program here, this while loop, we will return our registers. Alright, let's run this through Node here to see what this looks like here, and we have an error. Second is not defined. Yes, second here actually. Not a number. Okay, let's go ahead and console.log our instructions here. Let's do a console.log here. Yeah. Okay, what we'll go ahead and do, if is nan, we'll pass in our second here. We'll try this actually. So what we're going to go ahead and do here, first we set the A register to 5. We increment that register so it should be 6. We decrement that register so it's 5. We decrement it again so it's 4. Then we jump back one instruction here to this decrement here so it's now 3. Now, wait a minute. I just wonder how this is not resulting in an infinite loop. Oh, okay, I misinterpreted the JNZ command. Alright, what we need to do, we jump to an instruction Y, but only if X, constant or a register, is not 0. Okay. Yeah, I completely misinterpreted that. Alright, if is nan first is equal to true. If it is, then we're referring to a register here. So what we'll go ahead and do, let content const content equals is nan first, then registers at first, or parse int first. And then if content is not 0, then we'll go ahead and take our instruction pointer, minus minus, or rather plus first. Then if instruction pointer is less than 0, we set it to 0. Alright, let's try that. Console.log command first second here. Alright. Into game. JNZ. Alright, let's go ahead and have a look at the JNZ command here. We're going to go ahead and console.log our content here. Right. If it's not 0. And then we need to increment that by a second here. Parse that as an integer here. Alright, what is that second looking like here? Right. Plus equals here. Infinite loop. And that should take us to the decrement command here. Alright, let's go ahead and console.log that content again. Console.log content. Okay, let's go to that dec command again. Console.log registers at first here. Okay, what's going on now? Alright, let's go ahead and actually re-implement these commands here. Alright. First, we have the move command. Give me just one moment here. Alright, let's try this again here. First, we have the mov command, which copies the value of y, which can either be a constant or a register content, into register x. Alright, first we'll go ahead and check to see if we're going to go ahead and attempt to parse if is nan second. If this is not a number, then we are dealing with the contents of a register here. So registers at first is equal to registers at second. Otherwise, we'll do registers at first equals parse int second. Alright, what we're going to go ahead and do, we're going to console.log the contents of our registers at the end of each incrementation of our loop. Each iteration of our loop. Alright, next we'll do the inc command. We'll take the register here and increment it. And likewise with the dec command, we'll decrement that register here. Now the j and z command. We'll do let const content and what we'll do is we're going to check to see if first is a number. If it is not, and then we're dealing with the contents of a register here. Otherwise, we'll just go ahead and parse that argument as a number here. All right, we're going to go ahead and console.log that content here. Registers is in, and misspelled registers. And we do properly get to the content of that register here. All right, we'll go ahead and check to see if that content is not 0. And then if it is not 0, we'll go ahead and take our instruction pointer and decrement that by the value of the second parameter. And then if our instruction pointer is less than 0, as a result, we'll go ahead and reset that to 0. And then we need to include a continue command here, so we don't end up incrementing that instruction pointer again. All right, let's see what this looks like. And we have an infinite loop again. All right, let's go ahead and once again log our instructions here. Give me just a moment here. Yeah. All right, I'm gonna go ahead and clear this terminal. I'm gonna go ahead and clear this terminal here. And I'm gonna go. All right, where are we going wrong here? I'm going to go ahead and console.log our instruction pointer here. We should be reaching a decrement command here. Let's go ahead and console.log that here. Why are we... Okay, we don't seem to be reaching that decrement command though. I'm gonna go ahead and console.log our content here. We note that it's set to 4. Because we need to put that continue outside of our if statement here. I think I figured that one out here. Alright, so we start our A register at 5. We increment that to 6, decrement that back to 5, then to 4. We jump back to the decrement command, it's 3. We jump back to it as 2. We jump back to it as 1. And we jump back to it is 0. And then we check to see if this is 0, and it is 0, so we don't increment again. So we go ahead and jump to the next command here, which we increment again. And then this is our final register here. Let's go ahead and get rid of this console.log here. Let's go ahead and get rid of this console.log as well. Alright, let's go ahead and run some tests here. How about this one here? Let's go ahead and copy this array here. And let's paste that. Actually, we'll go ahead and do this. Do a simple assembler. Pass that array in here. Let's see what this looks like here. We have our A register at 0 and our B register at -20, which is what we want to see here. Let's go ahead and punch this into Codewars to see what this looks like here. Let's run these tests. Let's hit attempt. And we are good. Now, in this Kata solution, as well as more than one other Kata solution in this episode, there is a lesson to be learned here. If you ever find yourself getting stuck or getting frustrated, sometimes it's a good idea to go back a few steps and retrace your steps. There's always a chance that when you do that, you'll find out where you're going wrong and you'll be able to fix what was going on. In this particular case, when I was working on implementing the jump to instruction command, the JNZ command, something was going wrong, and that was resulting in an infinite loop. I was starting to get a little bit frustrated by it, so what I went ahead and did was erase everything in that while loop, and then re-implement all of the assembler commands. And then when I got the jump into instruction command, I found out where I was going wrong. I was forgetting to include a continue statement when I was jumping to or from to another command here. And as a result, the command at the end of the while loop to increment the instruction pointer was running anyway. That's what was causing the infinite looping problem here. To reiterate, it's always a good idea to retrace your steps if you find yourself getting stuck. Now, this would normally be the part of the episode where I would say that is going to do it for today's episode of Versus Codewars. However, I do have a little bit of a surprise for you this time around. The katas that you've seen so far in this episode are not the only katas I have recorded for episode number 38. Before I took a little bit of time off from filming, I had attempted to record some other katas, which was normally going to be episode number 38. The katas you are about to see are themed around fixing bugs, and this includes a new warm-up segment and 4 other katas. So, without further ado, enjoy this bonus footage from episode 38 of Versus Codewars. I hope everyone is having a wonderful and safe day today. Our katas today will be focused around debugging and squashing bugs. We begin today's warm-up segment with this bit of code you see right here. I will call your attention to the kata instructions here. Here we have an array of objects called data here. Each object in this array has 2 properties, a name and an age. Here we have a call to a function called getNames, which passes this array of objects in as its lone argument, and is expected to return the value of the name property in each of these objects here, but is not giving the expected results. The goal of this kata is to find out why and to fix it. Let's go ahead and get started here. Alright, here in the kata solution here, we already have some code here, and this is the code that's going wrong here. I'm going to go ahead and copy this into our local solution here. It's a function called getNames, and it takes that aforementioned array of objects as its lone argument. It runs that array of objects through the map method, and in the map method's predicate function, it is supposed to return the value of the name property of each object. And I can very clearly see where we are going wrong here. So what we're going to go ahead and do, we are using the ES5 function syntax right here. And whenever you're using that, you have to have these curly braces right here first. But you also have to use the return keyword when this function is supposed to return something. So I'm going to go ahead and type in return just before item.name to let this function know that it is actually supposed to return the value of the name property in this object here. I'll go ahead and punch this into Codewars and see if this squashes the bug, and it does. But before we move on to the next warm-up kata, what I'm going to go ahead and do, I'm going to go ahead and try implementing this with ES6 arrow functions here. So what we're going to go ahead and do, we're going to do const getNames, and we're going to have our data here. Now, whenever you're writing ES6 arrow functions that have only one line to them, you can go ahead and omit the return statement here if this function is supposed to return something. So what we'll go ahead and do, right after this arrow here, we're going to go ahead and do data.map, just as we did in the Kata solution here. Now, in this predicate function, we're going to use another arrow function here. And we're going to pass in the item into the predicate function here. And then just after this arrow right here, we are going to go ahead and do item.name. So, this is the Kata solution implemented with just one line here. We're going to go ahead and punch this into Codewars to see what this looks like here. And we are good on that. For our next warm-up kata, for the next bug that we have to fix. This code provided is supposed to return a person's full name given their first and last names, but it is not working properly. The goal of this kata is to fix the bug. Let's go ahead and get started with this one. Here we have a class here called dinglemouse. It has a constructor which takes the first name and the last name, and a method called getFullName, which is supposed to return the first name, then a space, then the last name, combined as a single string. Alright, the first issue here is this class has no member called first name nor last name. So, in the constructor function, what we have to do, we have to go ahead and use the this keyword and create a variable inside the this context here called first name, and we will go ahead and assign that to first name. Likewise, we will go ahead and do the same for the last name as well. Whoops. Now, the second problem is in the getFullName method here, we are not accessing our first name or last name in the this context here. And that is going to trip us up as well. So what we're going to go ahead and do, I'm going to go ahead and actually use a template string here. And what we're going to go ahead and do, in the first placeholder, we are going to reference this.firstName. This ensures that this references the first name member that we set up here. Likewise, we're going to do a space here, and then we're going to do another placeholder right here, this.lastName. And this, likewise, references the last name member that we set up here on the constructor. Alright, let's go ahead and punch this into Codewars to see what this looks like. And we are going to go ahead and hit test. And we have a problem. What is going on? The Clint instead got Clint space. Oh, okay. Alright, what we need to do then, we got some other bugs we need to address here. So if this dot first name, then return this dot last name. Likewise, if this dot last name, we return this dot first name. Let's go ahead and punch this into Codewars and see what kind of test this knocks off here. And we are good on that. For our next bug to squash here, we have to debug a function called getSumOfDigits that takes positive integers to calculate the sum of its digits. We assume that the argument is an integer here. Here we have some examples here. Looks like we are taking the digits of the given integer and then adding them together and returning the sum here. Alright, let's go ahead and find out what's going on. Let's copy this code in here. Alright, we have our integer here. Alright, we have our sum, which I would like to set to 0. Alright, we have our digits here. We are converting this into a string here. We are flooring this integer in case we are given a floating point number, and then we are converting that integer into a string here. Next, we have a for loop. We start at index I, and then we go to the length of the digit string. And yeah, I can see a lot of things going wrong here. Alright, well, actually, we are going to go ahead and do. We are going to go ahead and parse through each of our digits here for const digit of digits. And then we are going to go ahead and do sum plus equals parse int digit. And this should give us the sum here. And I really don't like the use of the word var, so I'm going to replace these with let and const. Alright, let's go ahead and punch this into Codewars to see what this looks like. Whoops. No, come on. There we go. Alright, let's go ahead and test this out here. And we are good on that. For our next warm-up kata, we have a function that helps us spam our hearty laughter, but it's not working. The goal is to find out why. Alright, here we have our function here called spam, and we have this number right here. And it apparently returns the string hue multiplied by a number. I would be actually quite interested in seeing what would happen as a result. So let's go ahead and test this out here. Console.log spam 4. I'm going to go ahead and run this through Node to see what this looks like. Node warmup multiply characters, and we get the not a number signature indicating that our return value here is, put simply, not a number. Alright, what the author expects this function to do is actually repeat a given string a certain number of times. This string hue a certain number of times. And there is a way to do that. The string object has a method called repeat that repeats a string a given number of times. In this case, what we pass in as our number parameter here. Running this through Node, we now see our properly repeated hearty laughter. Hue, 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 hue. Alright, let's go ahead and punch this into Codewars to find out what happens here. Let's hit OK. Let's hit test. And we are good on that. Finally, we have a function to detect the type of an object. It receives any primitive values or objects and returns its object type as a string, but it seems to be working incorrectly. Our goal is to find out why and fix the problem here. So here we have a function called object type, and it takes an object as its lone parameter, defaulting to null if no such parameter is given. And it returns a call to object.prototype.toString, the function object.prototype.toString, and it calls on that the function method call, passing in the object as its this context here. Alright, let's go ahead and test this out here and see what this looks like here. console.log. I'm going to do an array of some sample objects here. 42, false, a function, a string, an object, an array. Alright, I'm going to run each of these entries through the map method here. And we're going to call our object type function on each of the elements in this array here. Alright, let's go ahead and run this through Node to see what this looks like here. I'm going to clear the terminal here. We're going to do Node, warm up, check your args. And we have the following strings here. Object number, object boolean, object function, object string, object, and object array here. Let's go ahead and have a look inside these let's have a look inside these tests here to see what we should be returning here. Alright, we have some other objects here. What we're going to go ahead and do, we're going to go ahead and hit test here and see what we expect here. Undefined should return object undefined. Instead got object null. So it looks like one of these tests here is an edge case that this function is not catching here. Alright, let's go ahead and in our local solution here, we are going to go ahead and do object type. First, let's go ahead and do a blank object here, and then we'll do another call to object type and pass an undefined as the parameter here. Running this through Node, we get in both instances the string object null. And that seems to be what's going wrong here. So what we are going to go ahead and do, if type of, we're going to use the type of operator here, and we're going to pass in our object here. And what this will do is return a string form of the type of this object here without the bracket object voodoo here. So what we're going to go ahead and do, if type of object equals undefined, we are going to return the string object undefined here. Alright, running this through Node, and we still get object null here. Even if we explicitly pass in undefined. That's interesting. Okay. Alright, we're going to go ahead and do a console.log here. Type of obj. And they are both of type object. Okay, that's fascinating. What about the type of NaN, the not a number operator? Gives us object number. How about we try out the Boolean coercion trick here. Pass an undefined here. And we get false in both cases here. How about and obj is not equal null? Okay, that is interesting here. Okay, I'm going to have to do some research here. I will be right back. Give me a moment. 5, 4, 3, 2, 1. Alright, I think I figured out what's going wrong here. The issue is that our object was defaulting to null when we were calling this function with no arguments passed in. Now, if we pass nothing into this function right here, this object here will default to, will end up being undefined, and as a result will default to null here. Now, we're passing in undefined explicitly into the second called object type here. As a result, obj is being set to undefined, and as a result is being defaulted to null. And that explains why these are both turning up object null right here. Alright, I think I know what to do to fix this here. First, we're going to go ahead and get rid of our default argument here. Alright, running this through node, we now have an instance where both of our calls here are returning object undefined. But that's going to cause problems with this last test right here, because it still expects object null. I think I know how to fix that, and we're going to do so with the arguments keyword. Now, in JavaScript, functions have a default array, an iterable object inside them called arguments, which contains all of the arguments that have been passed in to the function here. Alright, what we're going to go ahead and do, we're going to go ahead and check to see if our arguments.length, the length of the arguments array here, is equal to 0, which tells us that no arguments were passed in to this function right here. We are going to return object null in that case. Alright, let's go ahead and run this through node again. Alright, we now have object null for our call to object type with no arguments, and object undefined for our call to object type explicitly passing in undefined. Alright, let's go ahead and punch this into Codewars to see what this looks like here. We're going to go ahead and hit test. And we are good. That concludes today's warm-up segment. I will see you in the next kata. Here, we have a large company which has decided to expand upon the functionality of their online text editor. We have been tasked with writing a new function that accepts a phrase, a word, and an array of indices. We want this function to return the phrase with the word inserted at each of the indices given by the array in the third argument. However, our current function only gets the first insertion right, but all of the following ones are out of place. The goal of this kata is to fix the bug. Here we have our function here called insert at indexes. I don't know why it's called indexes and not indices, but I digress. Here we have 3 arguments here. The phrase that needs to be modified, the word that needs to be inserted into the phrase, and the indices given by the indexes array here. Now we have a for loop here. We start I at 0, and then we go into the length of our indices array, and right away I see our first bug here. This needs to be a less than sign, not a greater than sign. And then we step up by 1 with each iteration here. Now, inside each iteration here, we take our phrase and we set it equal to a new string. That new string being a concatenation of the following. The return of phrase.slice, we slice at 0 and go to the character in the string at this index, and then we insert the word here, and then we go ahead and slice again from the index, the character at this index, to the end of the string. And then we return the phrase here. Alright, now I have a phrase right here ready to be tested upon here. It says, I really like Codewars, it makes me happy. And we are going to go ahead and run this phrase through our Kata solution here. And we're going to insert the string '(D) at the indices 1 and 26. Alright, running this through Node, we are going to see that it inserts our 'D correctly at the first index. However, the second 'D is out of place here, and we need to figure out why and fix it here. And I think the issue lies in the fact that we are modifying the phrase itself being passed in, when we actually need to use the original phrase as a reference to insert the word at the correct indices here. What we're going to go ahead and do, we are going to go ahead and actually keep track of a result string, and we are actually going to modify this result string based on using the original phrase as a reference here. So instead of modifying phrase, we are going to go ahead and modify the result string. And instead of returning the phrase, we will return result. Running this through Node, we now see that the running this through Node, we now see that the second 'D is inserted correctly. However, now the first 'D is not being applied here. Now, we need to find out what is going on here. And what we're going to go ahead and do, I'm going to go ahead and put a block here in this for loop here. And we're going to go ahead and console.log the result. I have a new idea here. It might not be the phrase that's the problem. Modifying the phrase that's the problem here. I have a new idea here. What if we tried using an index modifier here? And then every time we did an insertion, we would add the length of the word to the index modifier here. Oh, right. Not inside the brackets. We gotta do that outside the brackets here. Alright, that seems to have fixed the issue here. Now let's have a look at some edge cases inside of our Kata instructions here. If the index array is empty, we return the initial phrase here. I think that won't be an issue here. Alright, let's go ahead and punch this into Codewars and see what this looks like here. Go ahead and hit test. And the test pass. And we are good. So, what was going on with my initial solution that was causing this solution to mess up here? What I was doing, I was storing the modified changes to the phrase that we passed in to a separate result string. The problem here was that with each iteration here, whenever a insertion was being made to the result string, the previous insertions were being overwritten so that only the last insertion would be reflected in the string that was being returned. The other solution I was able to come up with was to use something called an index modifier, where we would go ahead and modify the original phrase string that was passed in. But with each insertion here, we would have a counter that we would keep track of, and we would increase that counter by the length of the word that was being inserted, so that all of the indices were being kept up to date with each insertion. Here we have a function that has to return the sequence of movie titles that match the string passed in as an argument. Here we have our titles array right here. This is preloaded in the Kata solution here. However, this particular function is returning some weird result, skipping some of the matching results. The goal of this Kata is to find out what's going wrong here. Alright, I'm going to go ahead and do a console.log down here. We're going to do search, and we are going to pass in the string OCK. Now, this function with this string passed in is supposed to return the strings Rocky1 and Rocky2. Let's see what happens here. Node FIXME, breaking search bad. For whatever reason, this function is only returning an array with the string Rocky1. Alright, we have to figure out what is going wrong here. So, let's go ahead and get started with this one here. Here we have a regular expression called search, and we are using the regular expressions constructor here. This constructor takes two arguments, which is our pattern and then our flags here. Here we're using the global flag to find all occurrences of this pattern in the regular expression, and we have the I flag, which tells the regular expression to ignore casing. Alright, we take our titles array up here and we run it through the filter method. And in this predicate function here, we have our title as the lone argument. We run this regular expression here through the test method, and we pass in our title right here. Now, the regular expression's test method returns true if it picks up a match, if the regular expression picks up a match in the string that is passed in. Alright, let's go ahead and console.log our title and our search.test title here. And as you can see, we have a Rocky1, which is returning true. We have a Rocky2, which is returning true. And this third one here is returning false. And for whatever reason...
Oh, that's strange.
Yeah, when we run this test method in the filter function without this console.log, it ends up returning an empty array. However, when we don't run this filter method with this console.log here, it returns Rocky1. And let's go ahead and play around with some of these flags here. No, maybe not. How about we omit the test here from the regular expression here? Alright, I just wonder if this... Yeah, let's run... Yeah, let's actually run this function multiple times here, because this is certainly some strange behavior being exhibited by the test function here that I will admit I have never observed before. Okay, let's go ahead and console.log our regular expression again after each call of search.test. That doesn't seem to be the issue here. Alright, I'm gonna be right back. Give me a moment. 5, 4, 3, 2, 1. Okay, I think I figured it out here. Alright, the regular expression objects in JavaScript are actually stateful here, and they keep some kind of state in them that modifies the result of functions like search.test here whenever the global flag is set in the regular expression. So, I'm going to go ahead and get rid of this G right here. I'm going to save that. I'm going to run this through Node to see what this looks like. And we now have the strings Rocky1 and Rocky2 in the returned array right here, which is what we want to see. Let's go ahead and punch this into Codewars to see what this looks like here. I'm going to go ahead and hit test. And we are good. So, what was the problem that was causing the search regular expressions test method to return true and then false for the very same string? Well, you see, when the global or sticky flag in a regular expression is set, that regular expression becomes stateful, and a last index counter is set in the regular expression that corresponds to the index of the given string where the match was found. The test method uses this last index counter internally to start searching the string from the index where that match ends all the way to the end of the string. As a result, when we were running the test method in our Kata solution here, it wasn't searching from the start of the string. It was actually searching at the point of the string after that first match was found. That explains why A, the string Rocky1 was being picked up by the filter method, but not Rocky2, and B, when we were calling the test method multiple times in filter's predicate function, the first time was returning true, but the second time was returning false. To fix this, we would have to remove the global flag from the regular expression. In so doing, the regular expression would not use this last index counter, and the test method would always start searching from the beginning of the string. I'm going to have more information and documentation on the test method from MDN in the description box below. Here we have a class that sets the age, gender, and name of a person. This class has a method, hello, which is supposed to show only those attributes which have been explicitly set. Furthermore, it is supposed to say those attributes in the same order they were set. Like in these examples right here, I will call your attention to the Kata instructions here. Like these right here. If we set the name, age, and gender in the explicit order here, it'll say these things right here. Or it'll say these if you set the age, gender, and name in that explicit order. However, it is not working properly, and our goal here is to find out what's going wrong and fix it. Alright, let's go ahead and get started with this one. First, I'll demonstrate this class right here. I have an instance of this class, and we set the name, age, and gender of a guy named someone right here. Let's go ahead and feed this in a node and see what this looks like here. FIXME hello. And it returns the string, hello, my name is someone, I am 44, and I am male. However, let's go ahead and set the age first. And it still says, my name is someone, I am 44, I am male. This is not the desired behavior here. We want to go ahead and show this greeting in the explicit order of when the properties are set. So we want this to say, hello, I am 44, my name is someone, I am male, in this particular instance. Alright, let's go ahead. I think I know how to fix this up here. Okay, this dot q. Maybe set up like a q here. And maybe set like a default behavior. Maybe not. Or maybe a set. How about a set? And then this dot q dot delete age, and then this dot q dot add age. And what we'll go ahead and do, we'll go ahead and repeat this for the other properties here. Sex, and then name. I'm going to go ahead and console.log are set here. Yeah, age, name, and sex. Okay. Alright, what we'll go ahead and do, let's go ahead and comment this out here. We'll do a let greeting. We'll set that equal to hello. And then we've got to somehow iterate through this set here. And I think I know what to do. For const attribute of, and we're going to go ahead and convert our set into an array here. And what we'll do, I'm going to do a switch statement here. And we'll do a case name. We'll go ahead and do greeting plus equals. We'll do a template string. My name is this dot name. we'll break there. And then we'll do case age, and we'll do greeting plus equals. We need to have this period here. Our template string, we'll do a space, and then I am this dot age period. Then we'll break, and then finally we'll have our case sex or gender. Greeting plus equals I am this dot sex. And then what we'll go ahead and do down here, we'll return our greeting. And actually what we need to do here, we need to do a ternary operation here. So if sex is set to M, we'll print male, otherwise we'll print female. All right, let's go ahead and test that out here. And as you can see, we have hello, I am 44, my name is someone, I am male. All right, let's go ahead and overwrite the name here somewhere. So now it's going to say I am somewhere. I am 44. I am male. My name is somewhere. I think that's where we're getting at here, because the name is being overwritten. The name is now being shown at the end here. All right, let's go ahead and implement some of these tests down here. Do set name. We'll set that to Bob. Set age, set it to 27. And then set sex to M for male. Printing that out, we get hello, my name is Bob, I am 27, I am male. Let's jumble these around here. Let's get this semicolon at the end here. Now we have 27 male and Bob. It says now, hello, I am 27, I am male, and my name is Bob. All right, let's go ahead and omit the age here. Now it says, hello, I am male, my name is Bob. And let's go ahead and omit the gender here. And it just says, hello, my name is Bob. And that is what we want to see here. I think we're ready to punch this into Codewars to see what this looks like. Let's go ahead and get rid of this comment here. Let's go ahead and copy and paste this in here. Let's go ahead and run these tests. And we got a problem here. What is going on here? Test multiple age. Okay, I imagine this is the chain calling that's going on here. Alright, in the Kata instructions it says when the same attribute is assigned multiple times, the hello method only shows it once. If this happens, the order depends on the first assignment of that attribute, but the value is from the last assignment. Okay, so maybe if we get rid of these delete calls then. I think this is where we're being directed here. Let's go ahead and punch this into Codewars to see what this looks like. I think the problem was the delete calls there. We were taking the attribute out of the set before adding the attribute back in to ensure that the attribute would be last in the chain. I think that's what's causing that test to mess up here. Let's go ahead and run these initial tests here, and let's hit attempt again, and we are good. Here is the better code solution of the day. Pay mind to the code snippet you see to my left here. Now, instead of a set like we utilize in our Kata solution, this Kata solution utilizes an object called output. This object will have keys that correspond to the attributes of this person, the name, the sex, and the age. And each key is associated with a value. These values make up the greeting string that will be returned by the hello method. Now, in the hello method, we put these components of our greeting together using the Object.values method. The Object.values method takes one argument, which is the object, the values of which we want to look up. This will return an array of those values. These values will be put in place in the order in which they were inserted into the object in the first place. Now we'll take those values and we'll join those together with a blank string separator, keeping in mind that each of these values start with a space. This ensures that the most updated values are put in the greeting string in the order those values were initially inserted into that object. Now we shift gears from squashing bugs to preventing bugs from cropping up in the first place. For this kata, the goal is to validate if a user input string is alphanumeric. The given string is never nil, null, none, or none, so we don't have to check that. The string has to have the following conditions in order to be alphanumeric. There has to be at least one character, so a blank string is not valid. Allowed characters are uppercase or lowercase, Latin letters, and digits from 0 to 9, and no white spaces or underscores. Let's go ahead and get started with this one here. Const alphanumeric. And we'll have our string right here. And what we are going to do, we are going to make use of a regular expression here. Const alphanumeric regex. And this regular expression will have the global and case insensitive flags here. Alright, we're going to go ahead and do a caret and $sign to indicate the start and end of the string. And this regular expression will be looking for any of the following: the letters A through Z and the numbers 0 through 9. And this regular expression will be looking for at least one of these characters here from the start to the end of the string here. Alright, now keep in mind we're looking for only the lowercase a through z. We have the lowercase a through z here, but we're also looking for the uppercase a through z here because of this I flag. Alright, what we're going to go ahead and do from here, actually, since we're checking the entire string here from start to end, we probably don't need this global flag here anyway. Keeping in mind what I said about stateful regular expressions earlier in the episode. Alright, we're going to go ahead and do a little console.log here. We're going to have an array of strings here. First, Mazen Kaiser. The string hello world, the password with a 0, and then a cavalcade of blank strings here. We're going to run this array of strings through the map method here. We're going to pass in our alphanumeric function here as the predicate. Alright, what we're going to go ahead and do here, we're going to return alphanumeric regex.test, and we're going to pass in our string here. Whoops. Alright, let's go ahead and run this through Node to see what this looks like. Node, not very secure. And we have the return values true, false, true, and false, which is what we want to see here. Alright, let's go ahead and punch this into Node to see what this looks like here. We're going to run these tests, and we're going to hit attempt, and we are good. Not really much to say about this one, but as it turns out, the curly brace 1 comma curly brace, which we use to look for at least one instance of any of the characters that we had in our regular expression, achieves the same result as if we had used the plus sign token in our regular expression here to look for at least one instance of those characters. And that is going to do it for today's extra long episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to this channel to see me take on more coding challenges on Codewars. As always, if you think there is anything I can do to improve on my code for the better, feel free to drop a suggestion in the comments section below. Also, if you are a Kata author on Codewars and you would like to share your authored katas with me, feel free to drop links to those katas in the comments section below, and you might see me take on those katas on a future episode of Versus Codewars. I hope you have a wonderful and safe day, and I will see you on the next episode of Versus Codewars.